Welcome back class 9 to the online chemistry classes. We are already doing chapter 4 atomic structure and chemical bonding. Till now what we have studied, what are atoms? Atoms are the smallest particle of an element that show all the properties of that element. And then we studied about element. What is an element? A substance which is made up of same kind of atoms are called elements. And what is Dalton's atomic theory? In 1808, John Dalton proposed an atomic theory which says all matter is made up of atoms. Atoms are electrically neutral. All atoms of an element are similar or identical. Atoms of different elements are different, like atoms of gold are different from the atoms of silver. Atoms of hydrogen is different from that of sodium. And the fourth one, atoms can neither be created nor destroyed. So all these 5 points are there of John Dalton's atomic theory, which you can write in copy and learn Dalton's atomic theory and all the 5 points. Then next one we studied about the modern atomic theory, in which 3 points are there. Modern atomic theory says that atoms are divisible, means we can break down the atoms into smaller particles, that is electrons, protons, neutrons. Number 2, atoms consist of subatomic particles. Subatomic particles means those smaller particles which makes an atom are called subatomic particles. Like protons and neutrons are present in the center of the atom, which is called the nucleus. Proton is positively charged, neutrons are neutral charged, whereas the electrons which revolve around the nucleus, they are negatively charged. Then second point, already done. Third point, atoms of the same element may not be alike in all respects. Like atoms of hydrogen you can take, they exist in 3 different forms, like 1h1, 1h2, 1h3 with different mass numbers. So that's why this one says that atoms of the same element may not be alike in all respects. They may not be similar in all respects. Similarly, carbon also show 2 different isotopes, that is carbon 12 and carbon 14, in which they have different mass numbers. Then we studied about the structure of atom, in which we found that the atom largely consists of empty space, and in the center there is a small area called the nucleus, which is positively charged. It contains protons and neutrons, and it is surrounded by the electrons which revolve around the nucleus in a fixed circular path, which is called orbit or cell. Then atom is electrically neutral. We studied why atoms are electrically neutral, because the number of negatively charged electrons that revolve around the nucleus is equal to the number of positively charged protons which are present inside the nucleus of an atom. So both the positive and negative charges of protons and electrons cancel each other, and the atom has no charge on it. Then we studied about the electrons. William Crookes, a British scientist, noted that gases are poor conductors of heat and electricity, but when a high voltage of 10,000 volt is given in an induction coil, is applied to a discharge tube, then these gases at low pressure, these gases become good conductors of electricity and begin to flow from cathode to anode. And since the rays are coming from cathode to anode, they are called as cathode rays, and cathode rays has similar properties of that of electrons. So electron was discovered by British physicist John Thomson in 1897. The properties of electrons are, electron already we have studied, it is, the mass is 1 by 1837 times the mass of hydrogen atom. Electron has a unit negative charge, and electron is very small, and its radius is 1 into 10 to the power minus 15 meter. Then we studied about protons. It was discovered by Goldstein. Protons are positively charged particles, and the properties of protons are the electric charge is positive on a proton. A proton spins around its own axis like a spinning ball, and the mass of proton is equal to that of hydrogen atom, which is taken as 1 atomic mass unit, that is 1 AMU. Then we studied about the neutrons, was discovered by James Chadwick in 1932, and some of the properties of neutrons are, number 1, like electrons and protons and electrons, neutrons are also subatomic particles. They are very small in size, and mass is more than that of proton, that is 1.676 into 10 to the power minus 37 kg. And for a particular element, the number of neutrons inside the nucleus are different. Like if I say the number of neutrons in hydrogen atom is 0, in case of helium it is 1. So similarly it will keep on increasing, or it may differ from each other. Then we studied about what are nucleons. Inside the nucleus, you know, there are protons and neutrons. So protons and neutrons together, they are known as, what is their nucleons. So nucleons is equal to number of protons plus number of neutrons which are present inside the nucleus of an atom. Then we studied about the Rutherford's atomic model and the discovery of nucleus, in which we found that Ernest Rutherford, he bombarded a thin foil of gold with alpha particles, and he found that most of the alpha particles went or crossed the gold foil without any deviation or without any changes in their path. But some of them deflected back at large angles, and some of them completely rebounded back. And what was the conclusion he had drawn? That atom is largely empty, because there is a small positively charged nucleus in the center of an atom, and then lot of space is empty. Around the nucleus there is fixed path called orbit or shell, and this model of Rutherford is similar to that of the planetary model, that is the solar system. Okay, then the nucleus, already we have said. What are the drawbacks of Rutherford's atomic model? In that book it was not mentioned. The drawbacks of Rutherford's atomic model was he could not explain that how the atoms are stable, and he could not explain the stability of atom, because any charged particle, when it is accelerated, like if any charged particle will keep on spinning or keep on moving from one place to the other, its energy will be, it will radiate energy, that it will lose the energy. To remain in the circular path, the electrons would need to undergo acceleration. They have to keep on changing their path as well as speed. Therefore, it will radiate energy. And loss of energy in the electrons will lead to the shrinking of the size of orbits, and in a short time, it will hit the nucleus. So, such an atom cannot be expected to be stable. Then we studied about the Bohr's atomic model. In 1912, a Danish physicist proposed model of atom, where he gave the explanation of stability of the atom. And what were his points? The Bohr's atomic model says that electrons in an atom revolve around the nucleus in a fixed circular path, which is known as orbit or shell. And each orbit or shell has a particular energy. That's why it is also called energy level or energy cell. Like the first orbit is called designated as K, the second one is designated as L, the third one as M, and like this fourth one as N. Okay, so these are the different orbits or cells, and they have fixed energy in them. That's why they are called energy levels or energy cells. An electron revolving in the orbit neither lose nor gain energy. When the electron jumps from an inner energy level to the next energy level, it will gain energy. When electron jumps from inner cell to the outer cell, it needs more energy to jump from, like if you have to jump from the lower level to higher level, you need to have energy in your body or spend energy in your body, then only you can jump. So similarly, the electrons also need to absorb some energy to move from inner cell to the outer cell. Similarly, when any electron will, this electron will change its path, and it will come from outer level to the inner level, outer cell to the inner cell, it will lose some energy. That is, radiation of energy will be there. That is what happens, that when any atom will lose an electron, when the electron is lost, it acquires positive charge. And when it gains any electron, it acquires a negative charge. Okay, because it disturbs the charge of an atom. You know that atoms are electrically neutral. They have no charge. So when they gain one extra electron which is negatively charged, it becomes negative. And when it loses one electron, it becomes positively charged. then the number of electrons that can be accommodated in the different orbit or cells, it is denoted or it is given by a formula which is known as 2n square rule. Already you have studied about the 2n square rule, where n represents the number of cells, like n 1 for k, l n is 2, here m 3, this one is 4. So if we talk about the first orbit, that is k, the number of electrons will be 2 into n is 1 square, that is equal to 2 into 1 is 2. So maximum 2 electrons can be accommodated, and likewise here 8, here 18, 32. But what does the rule say? The last rule, that electron will try to occupy only maximum 8 electrons and not more than that. Okay. Then next, what is valence electron, valence shell? Already we had done yesterday in the interactive class, that valence electron, the last orbit, this is called the valence shell. Valence shell or valence orbit. And the electrons which are present in it, they are called the valence electrons. Okay, valence electrons. So if asked what is valence electrons, the electrons present in the outermost orbit of an atom is called valence electrons. Okay. So next one is electronic configuration. The way in which electrons are arranged in different orbit or cell is called electronic configuration. Like if I talk about calcium, whose atomic number is 20, so how the electronic configuration, EC means electronic configuration of calcium. What it will be? First orbit 2, second 8, 2, 8, 10 plus 8, 18 plus 2. So this is the electronic configuration. Now if I have to draw the atomic structure of calcium, here only I will draw. So first orbit 2 electrons, this is the first orbit. Second 8, so I will write here 1, 2, 3, 4, 5, 6, 7, 8 electrons. Third orbit also 8 is there, that is in the M cell there are 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. And the fourth and the last orbit, that is N, it contains 2 electrons. So this is the atomic structure, this is the electronic configuration. That is what I told you to write in copy and practice it. Okay, it's already given in the book also. Now next we have to study is stable configuration. What is the meaning of stable configuration? Such an element which has got its outermost shell completely filled with electrons. For example, take neon. Neon, which is a noble gas, has atomic number 10. It means 2 in the first cell, 8 in the second cell. So outermost shell or the second cell contains 8 electrons, which is completely filled. So such electronic configuration in which the outermost shell is completely filled with electrons is called stable configuration. Okay. Now next we have the octet rule. Already studied yesterday only. What is octet rule? Octet rule says that atoms will lose, atoms will gain, atoms will share the electrons. Means either they can lose electrons, like suppose there are 11 electrons in case of sodium. Atomic number is 11. So 2, 8 and 1. 2 in the first, 8 in the second, 1 in the third orbit will be there. This 1 electron is extra, so it will lose that 1 electron. So when it will lose, it will become stable. Similarly, talk about the fluorine, which has 9. Okay, so it means 2 and 7. 1 electron is short, so if it gains 1 more electron, so here gain will be there, here loss will be there. And sometimes sharing will be also there. So when the atoms will lose, gain or share electrons to become stable, that is to get 8 electrons in their outermost shell, in the valence shell, to acquire a stable configuration, that rule is called octet rule. Okay. Now next, exceptions of octet rule. What is the meaning of exception? Where does this rule does not apply? Octet rule will not apply in case of helium, lithium, hydrogen. Why? Because these elements have only 1, 2 and 3 electrons in their outermost shell. Means total number of electrons they have is 1, 2, 3, because their atomic number is 1 in case of hydrogen, in case of helium 2, in case of lithium 3. It means they will try to complete their first orbit only with 2 electrons. So that is called duplet structure, D-U-P-L-E-T, duplet. Okay, so helium will have 2 electrons in its outermost shell. Duplet means a set of 2 electrons. Then we studied about the metallic and non-metallic atoms. Those atoms which has 1, like sodium has 1 electron in the outermost shell, 2 like in magnesium, or 3 electrons in the outermost shell or the valence shell, such atoms or such elements are called metals. If the number of electrons in the valence shell is 4, 5, 6 or 7, such elements which has 4, 5, 6 or 7 electrons in the valence shell, they can gain electrons and they are said to be non-metals. Okay. Then we have to study about atomic number and mass number next. Okay, next one is what is atomic number? Atomic number is denoted by a symbol called Z. And atomic number means number of electrons present, number of protons present in the nucleus of an atom. In the nucleus of an atom. Since number of protons and number of neutrons are different, so we can write instead of protons, number of electrons present in an atom is called the atomic number. Okay, and it is denoted by the symbol Z. So Z is equal to number of protons, same is equal to number of electrons. Like this also we can write. For example, Z is equal to 1 for hydrogen. It means hydrogen has 1 proton, hydrogen has 1 electron in its first orbit or shell. And the atomic number of an element is written on the symbol as subscript. For example, if I write hydrogen, where to write its atomic number? The atomic number is written here, subscript means 1. And the mass number is written here only, that is 1. Okay, 1H1 we can write. But now next, if I write oxygen, the next element, the symbol of oxygen is O. Atomic number is written here as subscript, that is atomic number is 8, so we write 8 here. And the mass number of oxygen, because number of neutron is also 8, so mass number is equal to number of electrons plus neutrons. So 16, this is the mass number, and this one represents atomic number. And this one is the symbol of the atom. Symbol of atom. So this way we denote or we write the atomic, this one mass number, atomic number along with the symbol to denote the atomic number of an atom. Now atom is electrically neutral, already I said about it. Now next topic which you have to do is mass number. Already I said about the mass number. So mass number is denoted by mass number. It is equal to, it is denoted by capital letter A. So it is equal to number of protons plus number of neutrons. Now you know that number of proton is same as the atomic number. So I can also write Z plus N atomic number, that is Z plus N, or I can, instead of writing this one, I can also write like if you have to find the number of neutrons. How will you get number of neutrons? Number of neutrons from this formula, A equal to Z plus N. So N is equal to A minus Z, that is mass number minus atomic number, or mass number minus, instead of atomic number, number of protons, or mass number minus number of protons is same as number of electrons. Okay, so instead of writing proton, we can also write atomic number, mass number is equal to number of electrons plus neutrons. Why? Because protons and electrons are same. I can also write atomic mass is equal to protons, electrons, or this one. So all three, 1, 2, 3 we can write different ways. Why? Because number of P, that is protons, is equal to number of Z, atomic number is equal to number of electrons. Okay, so in your book you can see now one example I will give. If there is a symbol and the question is asked like carbon 12, 6. This is the symbol given in the question, and it is asked find the number of protons, neutrons and electrons present in this question. Okay, then how to find it? This C is the symbol of carbon, so number of protons is denoted here, that is the atomic number is same as the number of protons, that is 6. Atomic number, that is Z, represents atomic number is 6. Then next, number of electrons is 6. All three are same only. The number of electrons I did, protons I did. Now number of neutrons I have to do. Number of neutrons is equal to mass number, that is 12 minus 6. 12 minus 6 is 6 only. Okay, so in this way we can get all. We can get the electrons also, protons also, neutrons also. Okay. Now next we have to study is isotopes. What are isotopes? Atoms of the same element that has the same atomic number but different mass numbers are called isotopes. And only 2-3 elements are there which are showing the isotopes, but hydrogen is the one which show. So what is the meaning of isotopes? Definition already I said. Isotopes means atoms of the same element. Atoms of same element that has same atomic number. That has same atomic number. Z means atomic number. Okay, you can write atomic number only. That has same atomic number but different mass numbers. But different mass numbers. Example, carbon has two isotopes, carbon 12 and carbon 14. Two isotopes are there. Now, next one, hydrogen has three isotopes, hydrogen 1H1, 1H2 and 1H3. So mass number is 1, 2, 3. And they have different names. No other isotopes have different names. Like the isotopes of carbon is called carbon only, carbon 12, carbon 14. But the isotopes of hydrogen has a different name. This is called protium, deuterium, tritium, according to the mass numbers. Okay. And the third one which is in your syllabus is chlorine, Cl. Chlorine has two isotopes, that is chlorine 35 and chlorine 37. So chlorine 35 and chlorine 37. Okay. Now you can see the structure also and try to draw the structures of each of them. Now next we have to do is the regions for chemical activity of atom. Already yesterday I said that why atoms show chemical activity. The reason is because they are unstable, because their outermost electron is not completely filled. I gave the example of that noble gases, since they have completely stable electronic configuration, so they do not take part in any chemical reactions. Those atoms which are unstable, they are more reactive. So reason is given there. Korsel and Lewis proposed that atoms can combine by losing, gaining or sharing of electrons to get the stable configuration. Except inert gases, all the elements have unstable electronic configuration. Therefore, they tend to acquire stable electronic configuration either by losing electrons, by gaining electrons or by sharing. So we can conclude that atoms have a tendency to acquire the stable configuration to complete their outermost shell with an octet or diplet. And due to this tendency, elements enter into a chemical combinations with other atoms. So during this process of combination, the nucleus of one atom attracts the nucleus of another atom with the help of a force of attraction, which results in the formation of chemical bond. Okay. So what is chemical bond? Chemical bond is a force of attraction between the atoms of two different elements that hold them together in a molecule. Like if I say hydrogen molecule, H2 is there, it means two hydrogen atoms are there. So how both the hydrogens are held together with the help of this chemical force of attraction. This is called the chemical bond. Okay. So chemical bonds are of different types. Next we will study about the chemical bond only in the next class. Three different types of chemical bonds, that is ionic or electrovalent bond, covalent bond, and the third one which is formed by the sharing of electrons. So we will study about them in the next class. Okay. So section exercises are there on page number 71. You can try it as homework. Let me know whether if any doubt is there. Like first question, an atom has atomic number 12. What is its valency? And what is the name of the element? Okay, first question I will say only. Section exercises, question number 1 is, an atom has atomic number 12. Okay, Z is equal to 12. The question is asked, what is valency? Let's see. First we have to do electronic configuration. 2, 8, 2. Means valency is 2. This is the valency, the outermost electrons. Number of electrons present in the outermost shell is called the valency. And what is the name of the element? The name of the element 12 is magnesium. M-A-G-N-E-S-I-U-M, magnesium. So you can try and write number 1 like this, number 2, 3, 4. You first try yourself. If any doubt, we can discuss it even in the that interactive classes also. Thank you.